In today's session, we will be learning what is the appropriate language to use when describing the transformations that have been applied to our very most basic parabola that we can draw that has been constructed from the equation y equals x squared. Over the last couple of lessons, we have learned that parabolas from the original parabola can be translated to the left or to the right, up and down, stretched vertically or compressed vertically. And as we were learning these different transformations, you probably heard some of the terminology that was used to describe the motion or the movement of these parabolas. Now we're going to solidify our understanding of how to describe these transformations by talking about the language that we use when describing what has happened to our parabola. So I just want to recap what each of the values in our equation indicate about the transformations that have been applied to our parabola. So for a quadratic equation in vertex form, y equals ax minus h squared plus k, our a value tells us a couple of things about the transformations applied to our base parabola. And when I say base parabola, just remember all parabolas and quadratic relations stem from the very basic relation y equals x squared. Okay. After having applied different values to this equation, we essentially transform the graph that we would get from y equals x squared to different locations on our graph, or we transform the shape of our graph. So our a value of our equation in vertex form tells us a couple of things. First, we look at the sign of a. And when I say sign of a, it could either be positive or negative. A positive sign, so when a is greater than 0, that means that no reflection has occurred. Or we would say no reflection over the x-axis. If a is negative or less than 0, that means there is a reflection over the x-axis. And it's critical for us to distinguish a reflection over the x-axis versus a reflection over the y-axis. That is possible, but we are only considering what a does when its sign is negative, and that is flipping our parabola over the x-axis. So for instance, if we have a parabola that opens upwards, then applying a reflection would flip it over the x-axis. And again, this is just a review of what we've covered already. So that's the sign of A. Now the magnitude of A. And when I say magnitude, I'm only talking about the size of the value of A, ignoring the sign in front of that value. Okay, so the magnitude of A. And when we talk about the magnitude of A, it could either be between 0 and 1. So that notation says 0 is less than A, which is less than 1, which means that the value of A is between 0 and 1. This is going to indicate that our parabola has been vertically or a vertical compression by a factor of A. Or we would say that the parabola has been vertically compressed by a factor of A. So when A is a value between 0 and 1, like 0.25 or 0.333333 or 0.1, then a vertical compression has been applied to our parabola. If our A is greater than 1, then we have a vertical stretch by a factor of A. Okay. And again, that is ignoring the sign in between. So let's say, for instance, we have an A value that is equal to -3. Well, the negative in front of that A value would indicate that a reflection has occurred, but the 3, so the magnitude of that number, would indicate that it is a vertical stretch by a factor of 3 because it is a value greater than 1. What about our H and K values? Well, H, as we saw in the last couple of lessons, H is our horizontal translations. So when H is greater than 0, that means that our parabola has been horizontally translated H units right. And just a quick review, remember in the equation, if you see a subtraction sign, so x minus h, that indicates that your h value is a positive value. And whenever your h is a positive value, that means that it's going to translate to the right. So when you're describing this transformation, you would say that a horizontal translation h units right has occurred. If your h value is negative, so less than 0, which in the equation would be indicated by a plus beside the x instead of a subtraction, then that means that the transformation that was applied was a horizontal, or it was horizontally translated h units left, or you can say to the left, right? But semantics. Okay, so horizontally translated h units right or horizontally translated h units left. Lastly, I'm probably going to have to write over some of this, but that's okay. Now for our k value. And we know that k changes our parabola by translating it up or down. So how do we describe that transformation? Well, if your k value is greater than 0 or positive, that indicates that our parabola has been vertically translated k units up, whatever k is. And then if our k value is less than 0, that's going to indicate that our parabola has been vertically translated k units down. And again, whatever those values of A, H, and K are in your actual equation, you would just input those into your descriptions. Okay, so one reason why it is important for you to learn this language of transformations is because when you are given a problem that describes the transformations of your parabola from y equals x squared to the new quadratic equation, you need to be able to use those descriptions to determine what the equation is. And similarly, if you were given the equation and asked to describe the transformations that have been applied to your parabola from the original y equals x squared parabola, then again, you would have to be able to use this universal language in order to express the descriptions of the parabolas. Okay, so it's a little bit more systematic, helps us all make sure that we understand the language and know exactly what is being applied to our parabola. Okay, so describing transformations of a parabola given the equation. So as I said before, if you have the equation of a parabola, then you should be able to look at those values of A, H, and K and determine what transformations have been applied to our parabola. Just a quick note that when you are describing the transformations, we usually or conventionally list them out from reflection and then vertical or vertical stretch or compression, and then horizontal and or vertical translation. Okay. So when given the equation, the first thing that we want to do is identify what our values of A, H, and K are in the vertex form of a quadratic equation, right? And remember, it has to be in the form y equals A bracket x minus h all squared plus k. Well, you're probably wondering, what happens if you're given an equation in standard form or even factored form? Well, there is a procedure for converting those other forms of a quadratic equation to vertex form, which you will learn in the next lesson. Okay, but for right now, the questions that you will be asked to describe for the transformations will all be given in vertex form. So, looking at the equation in vertex form, we have to determine what our A value is, our H value, and our K. Okay. So if we compare this equation to the y equals a bracket x minus h squared plus k, we know that our a is going to be negative 2. Our h in the equation, there is a subtraction sign between the x and the 4. That means that our h is a positive 4. Right? And if you don't want to put that positive there because no sign automatically indicates positive, that is fine. Right? But just to emphasize that this is a value greater than 0. And then we have positive 6 or plus 6 is our K. So how would we describe our transformations? Well, first, let's start with reflection. Because the sign of our A value is negative, we would say that there is a reflection over the x-axis. And as I said before, it is possible to flip this over the y-axis, but only for negative values of A will we get an reflection over the x-axis. So there's no point this year where you would have to describe a reflection over the y-axis. So please try not to confuse the two. I'm just stating it because it is possible to flip it over the y-axis, but that's not what our A value will do. It only flips it over the x-axis. So there is no ambiguity there. Next, what about the value of A? Well, the value of A is greater than 1, right? 2 is the value of A, or the magnitude of A. So we would say that there is a vertical stretch by a factor of 2. And if we were to actually calculate this out, we would see that from the original parabola, which is represented by the equation y equals x squared, all of our y values from that parabola would be multiplied by 2. That's why we say factor of 2. Or they're increasing by a factor of 2, which gives the stretched look of our parabola. Next, we're going to state whether or not there is a horizontal or vertical translation. And the order in which you describe those two translations, so whether it's horizontal or vertical, doesn't matter. Okay, so those are the only ones that you can flip the order of, and it wouldn't give you any different parabola graph. Okay, so starting with our H, we know that that is a horizontal translation. And because our value of h is greater than 0, it's going to go to the right. So this is a horizontal translation, 2 units to the right, or 2 units right. Okay. And we say units because on our scale for our graph, we haven't defined an actual unit for each step up our graph, right? If we had defined, or to the left or to the right on our graph either, if we had defined each space of our scale as a centimeter or a second or an hour, whatever the unit would be, then we would put that specific unit in the place where we say units. But this is the generic unit because it hasn't been described, so we say 2 units to the right. And lastly, our K value, which tells us if there is a vertical translation. Well, because our K value is greater than 0, it's going to move our parabola 6 units up. So there is a vertical translation 6 units up. And again, units because we haven't defined our unit, and we can assume that no unit has been defined unless it has been expressed in the question. One thing to note is that if your h is equal to 0, which is a possibility, then there is no horizontal translation, and the equation will look like y equals a bracket x minus 0 squared plus k. But we don't usually show that 0. So you're just going to see an a times x squared plus k. Some students will look at this and say, oh, my k value is my h because it's being added right to the x squared term, but that is not the case, right? This is the case where your h is 0. So if there is no horizontal translation, you don't have to state no horizontal translation occurs. Just state the translations that have occurred. For a k value equal to 0, if you had a k value equal to 0, your vertex form would be modified to y equals a bracket x minus h squared with no k value at the end. Okay, and again, there would be no vertical translation. Now we determine the equation of a parabola given the description of its transformations. And again, as we use these more universal ways of describing transformations, it makes it easy for most people to transform that language into the actual values of a, h, and k and put them into our equation. So a quick reminder of our base parabola that we keep referring to. Remember, this parabola is derived from the most basic quadratic relation y equals x squared. Okay, so we always plot our 0, 0, and then we have 1, 1, then we have 2, 4, then we have 3, 9. And again, we can plot this quickly by using our step pattern. After having done this 100 times, you won't even need your step pattern. But remember, our step pattern is 1, 3, 5. And it's the same on the other side as well. Okay, so this is the parabola that we are comparing to our transformed parabola. So what happened to this parabola to give us our new parabola? So a lot of times in the questions, they are going to reference the original parabola y equals x squared and then describe that it has been transformed and describe the actual transformations. So let's look at this example here. State the equation of the resulting parabola if the original parabola y equals x squared is reflected vertically, compressed by a factor of 1 over 4, translated 3 units down, and 5 units left. Okay. And notice how in these descriptions here, it said translated 3 units down. They didn't say vertically translated or horizontally translated, but they did give us left and down, which is enough for us to figure out that it is our vertical and horizontal transformations. So let's analyze this description. First, we have a reflection, which means that our a value is going to be negative. Then we know that there is a vertical compression by a factor of 1 over 4. So 1 over 4 is going to be the magnitude of our value of a. If you gave this to me as a decimal, so 0.25, you wouldn't be wrong either. They're just some fraction values that are non-terminating, so we want to leave them as fractions. And I would encourage you to leave your values as fractions instead of converting them to decimals. But in this case, it wouldn't matter because you wouldn't have to round this off. Then we have a translation 3 units down. That is our vertical translation, which is our k value. So it's down, which means that our k is going to be a negative. And we have a horizontal translation 5 units left. Left means a negative h value, and it has moved 5 units, so it's going to be a negative 5. Now that we know all of our values for A, H, and K, remembering our vertex form, which I'm just going to write on the side here, y equals A bracket x minus h squared plus k, we just input our values for A, H, and K. So negative 1 over 4, x minus h is negative 5, so we're going to put a negative 5 in there. And then our k value is a negative 3, so we're going to input that. Okay, this is correct, but as we always say when we're doing these types of problems where we have to substitute values into an equation, we don't like those signs, those double signs right beside each other. So we want to simplify that. Y equals negative 1 over 4, times x negative or minus negative 5 is the same as writing plus 5 squared plus negative 3. That's going to give us a minus 3. And notice how when our h value was negative, the sign in the equation is positive, and that is why. Right? When you put a negative into the general equation, which is x minus h in that section here, that subtraction sign is going to convert the negative to a positive, and it would convert a positive to a negative. So you don't have to show me that previous step there. You could just jump right to the positive if you know your h is going to be negative. But this is the understanding why it's positive in the equation but negative outside of the equation. If a question requires the expression of the equation in standard form, y equals ax squared plus bx plus c, then we would just simply expand and simplify the vertex form. So right now we are given the equation in vertex form, but sometimes the question will ask us to express it in standard form because standard form sometimes has some important information to give us as well. So how do we do this is that we're going to first expand our brackets. Okay, so remember, BEDMAS. We want to expand the squared binomial first, then do the multiplication, and then do the subtraction. Okay, so expand our brackets. Y equals negative 1 over 4. And remember from the last unit, we learned that shortcut for squaring a binomial. We square the first term, and then we multiply the two terms inside the bracket. So 5 times x is 5x, and then we times that by 2. So plus 10x, and then plus the square of the last, which is 25, minus 3. Then we want to use our distributive property to multiply the negative 1 over 4 outside of the bracket to all of the terms inside of our bracket. So we have y equals negative 1 over 4 x squared plus, minus 10 over 4x minus 25 over 4 minus 3. So once we have applied our distributive property, so a recap of last unit, we can take down our brackets. Lastly, we want to simplify all of our terms. And notice how this term here is a fraction that can be reduced. Make sure that you reduce all of your fractions as well. That is part of simplification. So we have y equals negative 1 over 4 x squared. We can divide a 2 out of the top and the bottom of this fraction. So that's going to leave us with a 5 over 2x. And then negative 25 over 4 minus 3. 25 over 4. The 3 can be rewritten so that it has a common denominator as a 25 over 4 as 12 over 4. So negative 25 minus 12 is equal to 37. So I'm just going to erase it and write the simplified form. And there you go. And note, for the standard form of a quadratic relation, you can have fractions. That is it for the language that we use when we are describing transformations. Below is a list of your homework. And on the worksheet, there are some practice questions. Please make sure that you get those practice questions done, along with the one textbook problem on page 224, number 9. So this is in section 4.3 of the textbook. Good luck.